Sequences. Gotta love sequences. This particular arithmetic sequence seems to go on forever. We could write out all the numbers of the sequence, but it would take us a lifetime. That's why there's a dot, dot, dot. It's going to keep on going. Most people would notice that every term of the sequence continues to increase by 3. So they would probably say that the next term in this sequence has got to be 3 more than 16. 19. And then the next term would have to be 3 more than that. And we could continue this method if we wanted to find something like the 40th term of the sequence. And you continue to add 3, and then add 3, and then add 3, and then add 3. But this is kind of an inefficient method. I don't like doing that. I wonder if there's a formula, an explicit formula, that will tell me any term of the sequence that I want, such as the 40th, or the 5,000th, or the 631st. There's got to be some sort of efficient method to do that without having to continue to add to find the next term. Well, the book suggests one way to find an explicit formula for a sequence. I prefer a different method. As you already noticed, it appears that the common difference of this particular sequence is 3. That's going to help us write an explicit formula. The other thing that we need to know is, come up here and remember that if this represents the first term of the sequence, I'll call it a sub 1, and this number here is the second term of the sequence, call a sub 2, and the 40th term of the sequence I could call a sub 40, the 5,000th I could call a sub 5,000, the 631st I could call a sub 631. The other thing that's going to help me find an explicit formula is a term that doesn't really exist, because it's not actually part of the sequence. It's kind of a phantom term, and we'll call it the 0th term of the sequence. Again, I like to call this the phantom term, because you don't really see it. But in this case, if you continue to add 3 to find the next one, well, what number would come before the first term? What number, when you added 3 to it, would give you 7? And just subtract 3. This phantom term, in this case, would be 4. You guessed it. So here's a great way to write an explicit formula for a sequence. And all you need is 2 things. You need to know the common difference, and you need to know what this phantom term is. You can write any explicit formula. We'll say the nth term can be found by taking the common difference times n plus the phantom term. We'll call a sub 0. So in this particular instance, in the sequence that we're looking at here, a sub n is equal to the common difference, 3 times n, plus the phantom term, 4. Now this wonderful formula here is going to help us find any term we want in the sequence. So if you wanted to find, as was suggested up here, a sub 40, the 40th term of the sequence, simply replace n with 40, and evaluate. 3 times 40 is 120, plus 4, 124 is the 40th term of the sequence. Well, what if you wanted to find the 631st term of the sequence? a sub 631. Again, just simply plug in 631 for n. Let's see, 631 times 4 would be 1,893. Add 4 to that. The 631st term is 1,897. Oh hey, let's try our last one. To find the 5,000th term. Again, start with the explicit formula. Plug in 5,000 for n. So let's see, 3 times 5,000 would be 15,000. And adding 4 to that, the 5,000th term of the sequence would be 15,004. Cowabunga.